section. So we're talking with Daniel Wartz, and we're going to do a little run through of how to use the PC board manufacturing system. We're going to go through an example.
Hopefully I don't stumble through it too much myself, but I got this board designed from Dr. Deese. This is a pretty complex board, but the point being, to get the board into IsoPro, you have to import the Gerber files first. The Gerber files are exported from EagleCAD or however you can get them. And you do that by going to File, Import. I do Gerber files first, and then I already have them saved here. I already imported it, so you would select and open. And then you would do the same for the drill files, which is right here. I hit export. You would import the drill files, same thing, that's created in EagleCAD or whatever similar program, and that brings everything into IsoPro, and IsoPro communicates with the actual QuickCircuit machine. So once it's actually in the program, you can kind of go layer by layer. Here I'm going to disable a few layers that are superfluous, because he has a silkscreen layer on here and a few solder mask layers, so I'm just going to hide a few things on the left bar here.
So what do you mean by he? You mean the
Dr. Deese, I'm sorry.
Dr.
Yeah,
Deese.
because this is a board Dr. Deese designed here.
Oh, okay.
So just for demonstration purposes, I'm going to hide all the layers except for this top. And this is just, I think, this is either top or bottom layer. You can do up to 2-layer boards simply by flipping the copper upside down on the machine. But the point being, get the layer you want to start with, and then you have to actually initialize the machine. I've already done that, but that's done by going to Mill, and then this would be initialized. Here it's reinitialize. I might as well do that right now. And all that does is bring the machine to its home point. That's going to bring it over here, basically. I wish there was a way to make it go a little bit faster there. But that is what it is. And it's going to stop over here, kind of. See, it clears that pin right there, but that's something you would have to be careful about. If that base is too low or something, you don't want it to scrape on that pin or anything. That being one of the 2 pins you have to set with an 1/8" drill hole in order to fix the board here. And then I also have 2 pieces of tape on either side.
Pin on the far side.
The way it's supposed to be done is right in the middle of the board material. The reason I have it on a far side right now is because of the way the home position is mapped. I think in IsoPro it just seems to be kind of offset to one side, so I can just to get the thing up and running, I offset the holes a little bit.
Okay. So the whole position is as on the lower right hand corner of the board, or however, I don't know. Oh, actually the top of this is why don't you show us where the top of the board is, like where's the
well, in this case, I guess it's relative to however you import the files, but I guess this would be treated as the front right now, and that would be the back.
Is that right? Okay, because I thought they were rotated 90 degrees possibly. That's not what you thought?
You know, the X and Y are rotated with respect to the program. I couldn't tell you exactly what they are, but that's, the axis, you do have to be aware of that, because I'll show you when you align the machine.
So just to point out again, so this is, there's a pin that goes through here. There's a hole that has to be drilled through the board.
It's 1/8".
Okay, and you just press fit the pin through the hole, and it goes into a hole in the actual platter of the machine. And then there's another slot that runs. The slot runs all the way up and down the machine in this axis, a groove, and then the other pin just rides in the slot, and then the 2 pins together keep the board immobile and give you a reference that if you were to flip it, you would be able to register the front and the back sides of the board.
That's why you should have the holes in the middle right now, again, just to demonstrate, because of how the axes are, I just have it on one side, but these should also be, I'm pretty sure it's called 5/8 of an inch from each edge. They want the holes. I guess that doesn't have to be exact as long as it's aligned to the center of it. That's the
But even
important
anything
part.
about the hole positions don't have to be precise.
Right.
I think, right? Because you flip the board and
well, as long as it's a good mirror of itself.
Well, as long as the holes are snug, right? As long as they're
Yeah,
there's not a lot of
they
slack
are
in the
pretty
hole.
snug.
Right,
They're very
that's
snug.
all
You
that
gotta
matters,
kind of work them in a little bit. But,
Yep. Okay.
And then there's also worthy of mentioning. There's a layer of poster board material under the board right now. That's probably not ideal, but the reason it's there is to provide a barrier, I guess, in between the bottom layer of copper and the machine's what's it called, the face itself.
Yeah.
Obviously, you don't want to actually run the tooling into the face of the machine, as that's going to cause irreparable damage. So once your machine's initialized and everything, the tool that I have in there right now I'm going to leave, but I guess I'll go through the process of how if you change a tool, change the orientation of the machine and everything. So the first command that's definitely good to know is jog. So what jog is in IsoPro, there's an icon for it right here, and you can also get to it through mill and then jog, or Control J. And jog is how you want to move the machine at any time while it's on. It's just controlled with the 4 arrow keys. So up, down, left, right. I can't go left, right. So that's up, down. That maps to the x-axis, see how it is here. So you're right, up, down maps to the x-axis. And then right, left maps to what is the y-axis on here. So if you want to orient the tooling on the circuits, you use jog. Jog could also be used if you ever wanted to change a tool to bring the whole head assembly out to where you could access it. But there's good functionality for changing tools while you're running the design anyway. So that's jog. Another way you could see where you're aligned is right-clicking anywhere on the work surface, going to machine, and then jump to cursor. I do this just to find out where your actual area would be that the machine's working on the copper. So I do machine, jump to cursor at every corner basically, just to make sure, get an idea of where the design is actually going to be done. You can see that's a test piece of copper right there, so there's going to be some things that are overlapping it. But if you were to actually do your own design, obviously, get a nice piece of bare copper. So I'm just making sure that the 4 corners are in good copper on the machine. So that would be where the design gets cut out. Then the next step here is, I guess I could go to actually try to run this layer now. And to do that, you can right-click on the layers menu, and there's an option to run layer. So you get a pop-up, yes, you're sure you want to build this layer. Before doing this, actually, you would want to make sure that you have all the tooling defined. So I'm actually going to back out of this right now, go into there. There's a tools menu in the top here, tools and apertures. Apertures comes from the Eagle file itself, to my knowledge, and that defines things like the tolerancing between traces. And then tools itself just defines the tools that are actually going to be used on your design. So here I'll add the one tool I have in there now. This is using a standard spindle. Plant some more drills, and I'm going to add a tool here. I'm adding the T1 mill, which I just know is 12 mil diameter. It's 60,000 RPM. And the mill speed is in inches per minute. That just defines, the RPM defines how fast the head spins, and mill speed defines how fast the actual assembly moves. It defaults to 60. Anywhere between, I found, like 30 to 60 tends to be a logical value where it's not flying or anything.
Have you had issues where you tried a faster mill speed and saw problems?
I wouldn't say I've had problems, but I just don't know what the machine can handle necessarily.
Okay.
So I guess I'll show you the effects of that after.
Okay,
So
that's fine. So
I'm defining this as
50 and 60,000 RPM. And where did you get that 60,000 RPM?
that just came from the spec on the machine itself. The head can go, I think it was 6,000 to 65,000 or 70,000.
Does each bit have a recommendation on RPM? Do the different bits have?
I can't tell you for sure, but yes.
Okay.
I don't actually know any of them besides this
not
T1 mill.
Okay.
But they don't give all the information on it. Like, they just give you the size on the tooling. So like these drill bits are 32 mils. And then you would have to figure out what RPM and what mill speed you want to use with that.
And so for this this mill that you've chosen, which is did you say 10 mils? The 12.
This is 12 mils. This is the T1 mill.
So does your design allow for 12 mil spacing between traces?
That's something that is done in the Eagle file.
Right, but like, how do you know? Like, if you needed smaller than 12 mil spaces, will this like software tell you that you also now need to load a narrower?
Yes,
bit?
actually, that's something that I know that functionality exists. There's something called a tolerance check that you can do in this program, where when you have your tool table defined, each layer has its own tooling already defined, and same thing with the drill layers. So I know I haven't actually done that myself, but I know that the functionality is there, that it'll run through the whole design and tell you, I guess, whether or not your tooling actually makes sense.
Okay.
Again, I know that's called tolerance check.
So
I haven't actually been able to do that myself yet,
Okay.
but I kept kind of high level, I guess, with this thing.
So if you, instead of giving it a 12 mil tool, gave it a 50 mil tool or something like that, and what would it tell you if you try to run it? If you just try to run the
I believe if you run it without doing a tolerance check, it would just overrun itself.
Meaning that it'll just actually like make a bad. It'll just create a bad.
I believe so. Again, I wouldn't say that with 100% confidence, but
so
that would be my expectation.
Okay, got it.
Yeah. But that's something that I think does come out of the Eagle files too. So it's kind of a double check that's done.
Okay. All right.
So anyway, something you can do now is test the depth of the cut, because that'll help you know whether or not you inserted the tool at the right height and everything. So an easy way to do that is to simply right-click on the work surface, go to Machine, and then there's Test Depth of Cut here. First, I'm going to jump to Cursor just to make sure I'm going to test at a good spot. So the machine is just moving to the point I defined. And now at that point, I'm going to right-click again, go Machine, Test Depth of Cut. And then that just moved to where I had it, and this menu comes up to define the tool size, feed rate, and spindle speed again. This is a 12 mil tool. And this is a good way also to experiment, I guess, with different feed rates and spindle speeds, because this is a quick thing that's done. So if we go spindle speed of 60,000 RPM and a feed rate of, let's say, 50 inches per minute, because that's what I defined in the tooling table already. What the machine did there, it just made this cut right here. And there's a visual in the manual to look to see what you're actually supposed to see. Let's see if I can find that real quick. The vacuum also should be on right now. The T-Tech guy said it comes on only when the machine's actually on. Although it still does seem to leave some some specs there. So I'm not actually fully sure if the vacuum is working, but I'm just trying to find the visual real quick. Because there's a pattern that you can see in there to tell whether or not the cut depth is correct. No, it's here. If I can't find it, I'll just skip that for a moment.
Is this a tool with a V-shaped head that the width of the cut depends on the depth of the cup? Is that?
Yes. So this, you can see it's V-shaped at the very bottom of it, but the depth of this cut, I'm fairly sure goes just barely before the total width is reached.
Mm-hmm.
And again, I did a few of them earlier with different cut depths, and you could just kind of tell what's right because it fills itself in and it doesn't cut much deeper than the actual copper. But I'll find that visual somewhere that tells you what it's actually supposed to look like. But and again, the cut depth is just set by these two adjustments on the machine. They're an upper and lower limit, and then also defined by where you actually put the bit in the head. Where I have it now is essentially where you want it. You want it minimally above the copper because the least amount of acceleration the machine gets in the Z-axis, the least chance of it is of causing unexpected damage or anything to the board. Because you can imagine if it's got a lot of spacing, it's going to fly in until it actually hits it.
So, are you saying that when you actually inserted the tool and tightened on the set screw,
yes,
was there sort of a discretion that you applied to how deep you inserted the?
There's a little bit of discretion, but there's also some tools that you can use to do it. Like it comes with these feeler gauges. These are all a little bit too small, I would say, for actually setting it, but you could set it like slightly higher than the biggest feeler gauge here, or something, just to keep it, just so it's barely above the material.
So once you put in the bit, though, you can use these screws to also fine tune it, right?
Exactly.
And did you do that?
That's exactly what I did.
You adjust these, and what's the procedure for adjusting the depth of the?
So there's a couple of ways you could do that, I guess. What I did was I jogged the machine off the work surface, and then again use this to just see how far the lower limit is. So all the way down, you make sure that you're not going to cut through the bottom layer of your material, and then you would set either the physical position of the bit head, or I think it makes more sense to just align it close and then change the two set screws. So you would set that for your optimal depth, I suppose. You can see there's a lot that can go into this thing.
Two screws, okay. And why do you care about the upper limit? Why do you care how high? Oh, you said you wanted to make it close down.
Yeah, because the way the machine works is it uses this stopper foot to tell when it's actually contacting the board material. So if it's set too high, I guess there will be too much of a Z-axis force once it hits the board, which could it could damage the tool. It could decrease the life of it. I know. And that's just something to be avoided in general. So we have a good cut depth. We have the right tooling. Obviously, you would set this up with the tooling that you actually start the design with. So, you know, it maybe makes sense to do all your drill holes first, they suggest. But,
is that right?
But the way I have it here, this is just a layer for this T1 mill, and I'm going to skip a couple of the other ones because we don't have, I think, all the tooling.
Why do they suggest the drill holes first?
That's just how it comes up through the program, I guess. But it shouldn't matter, I would think, either way.
So, when you say that's how it comes up in the program, what do you mean by that? Like, 'cause you just did the...
I'll show you that, actually. So this might as well try to run this layer now. So I'm right-clicking on layers. I go Run Layer. It's going to say yes to this. And this is the layer tool list. This one was defined by Dr. Deese on this file. So this is what he had from Eagle, and what we have doesn't fully correspond to that, but I'm doing this as a demo, so I guess we're just going to work through that issue. But this is what Dr. Deese defined on this board to be the necessary tooling to do this layer.
I'm not completely when you say the necessary tooling. I mean, when you in Eagle isn't assuming that you're going to use a milling machine. Eagle's assuming that you're going to
or maybe this is tolerancing then.
Yeah, so what are the two columns here? What is it telling us?
D-cod, I think this is just some number, but the size is in mils, I know. I wonder why there's not a type defined, because some of these would be drills, some of these should be end mills. This is essentially as far as I've gotten with it, though. But, maybe limit switch error. All right, so there's a limit switch error. I'm not exactly sure why that was, but when that happens, it means that the machine is too far on one axis or another, and it stops itself from damaging itself.
So where did you see the limit switch error?
It just came up when I tried to run the layer, but I'm not exactly sure why that came up, because I tested the 4 corners of this with the cursor, and I know that it's inside of the bounds of the machine. Maybe it's too close to this, so I'm just going to move this over a little bit. I guess this is a good point to show you how you would actually offset is the command used to change the location. So I just changed this layer to edit. I'm selecting everything. I'm going to go edit, offset, and we're going to move this 0.5 inches on the x-axis. So that should still be a fine area to mill at. And hopefully we don't get the limit switch error now. We'll find out though. Okay, so that was convenient. So what it's doing, it's going to put itself into tool change position now, I'm pretty sure. Okay, so now it's asking us to insert the 40 mil tool. Again, this is something that was defined, I'm pretty sure, in the design itself, or when Dr. Deese did this. We don't have the 40 mil tool, and I know when I did this earlier, this tool was only used for a couple of holes on it, so I'm just going to skip it and then show once it gets to the 10 mil tool, because that does the actual traces, and that one's close enough to it, I think.
Is this for drilling? Is that why it wants the 40 mil tool?
Yes, I believe so. And maybe that's why I think drilling goes first. Maybe that's just how it came up when I did it. But I'm going to skip that one. So here's the 10 mil tool. This is what's going to do a lot of the traces. So we're going to define that this is an end mill. The T1 mill tool is an end mill. Again, you would define your RPM and your feed rate. So let's go 60,000. See, this is defaulted to 8, which is a lot lower than I've used before, but I mean, there's an element, I'm sure, of there's an art to getting the perfect feed rate and RPM, but I'll just set it to that. Now it's just runs the traces.
Recommend safety glasses?
I guess it looks like the vacuum is working. As long as the vacuum is working, that would check everything, but I'm not going to say that it will hurt to wear safety glasses either.
Yeah, so from where I'm looking, I see a distribution of sorry.
I might have to stop it because this layer is going to take a while. You can see a status screen on the program right now.
So, and I guess I didn't realize, but it says that there's an hour left. Okay.
Yeah, so there's a lot of traces to run on this, and with the feed rate set as it is, it just knows how long it's going to take. Because there's X inches to run and it's X inches per minute.
What's on screen there, is that reflecting the cut that is made so far? It's basically just mirroring on screen
exactly
what the machine is doing. And I see that there was no separate step to convert from the traces to the milling away of the spaces. So like, in order for this machine to work, it takes every copper trace,
negative, right?
It's like sort of a negative, it has to make an outline. It has to isolate every trace.
Right.
And there's no separate step. You just tell it to take the Gerber file and implement it, and it figures out it does that isolation without a separate operator.
That's my understanding of it right now.
Okay.
The fact that you brought it up gives me a little bit of second guessing of that. But we'll see how it actually comes out. I mean, this program is set up directly to run with the mill, so Logically, I would think so, and every tutorial I've gone through has said that there's no extra step. There's nothing about that in the manual. I think maybe that, you know, when the tolerances are already defined, it knows the tooling size. So running this layer, it's essentially isolating the traces that exist there. I can stop this on that too. I'm not going to go the whole thing. If you ever wanted to, you can go to mill stop on the mill menu, or pause.
So, have you ever
So I just paused
seen
that.
it go when the, have you ever tried running it without the vacuum thing on?
I haven't.
Okay,
I can try that right now.
No, that's okay. I'm just wondering
flip this and
what
keep
would
it
happen,
going.
like, because there does seem to be some amount of shards here.
Yeah, there's a
you can see,
lot,
like,
if
quite a
anything.
bit, yeah.
The vacuum power is on and it's plugged in, and the T-Tech guy said that it only kicks on when the machine's actually running.
Yeah,
so it's hard to actually tell because the machine's loud enough that it would drown out a vacuum noise.
Yeah.
Although I did see that it collected a lot. Possibly the vacuum is just not powerful enough.
Possible, yeah. And is there seems
I'm
to be
just
like
going to jog the machine out of the way right now.
Yeah, it seems like there's like a shard on the bit, kind of. Is that the way? Because I think I've seen it spinning around.
Oh, there's one that's been left on there.
Is that? Can you see what I'm talking about?
Yeah.
Okay. I wouldn't touch it, but yeah, not with my finger, right? Exactly. You know,
Let's
it's,
see. Yeah, let's see what this is. This is the Allen wrench that's, that was just magnetic on there, I guess.
Okay.
This is the Allen wrench that's used to change the bit.
Yeah,
there's a little set screw in there. Yeah.
Yep.
So let's take a look at this anyway. I don't want to just, I guess I could just blow it away.
Yeah, we can see it very well from here. Yep.
So now this, it called for a 10 mil tool, and this tool is actually 12 mils. Again, I just wanted to display the full functionality here.
And
but
you told it was 10 mils, even though it's
But
12.
yeah, so it thought it was 10 mils, so that can explain some of the overrunning, like over here, I think.
Yeah. So things should have been. It maybe.
So it should, and maybe it is going a little bit
traces,
too tight or a little bit too deep. But again, that's just, you really got to do your due diligence if you're making a board on this. To demonstrate as much as I can there.
Yeah.
And that's essentially as far as I've gotten that.
Okay.
You have all of the information about tolerancing, tooling. That all comes from, you would define that in your Eagle design, and then you would make sure you run tolerance checks. Eagle has the electrical design check that would make sure nothing's too close either.
Yeah. So when in order to change a bit, we don't necessarily have to do it, but do you bring it? Where do you bring the tool?
There's actually a function to change the tooling, and all that does is brings it to that point that was in the middle of when it was initializing, when the whole head came over here, and was pretty much at this point.
So it brings the edge.
This is the defined tool change point. So if you were, I'm pretty sure there's a tool change command. I unpaused it. I'll pause it. Sorry, I have to actually stop it. Okay, so now it's stopped. If you go to mill and then tool change is going to bring that. Oh, the tool change position's a little off. So right now it thinks that is the position to change tools, which is not exactly where it wants to be.
So do they recommend that you actually turn the power off to change the tool? You actually?
I haven't seen that. It's a good logical thing.
Yeah, I would want to do that.
Yeah, it's a good logical thing because, even if you're not the only one here, maybe somebody hits play if it's paused.
Or there's a software bug or whatever.
Or there's a software bug, and not that that's
it seems like the safe thing to do would be to turn the power
and it's
down.
easy enough to do that right there. And that's the power switch on the T-Tech machine.
Yep. Okay.
So you would power it off, jog the tooling, jog the head to a point that you have access to it. undo the set screw, and then put your actual tool in.
Yeah. When you say jog the head, actually you can't move the head when it's off. Is that right? You can't manually move the head.
Don't know.
It looks.
You're not supposed to, and you
yeah,
can't.
it looks like there's this worm
both.
screw that's it has to be running on that worm screw.
So you would power it on and then use the jog command
Mm-hmm.
just to get it where you wanted.
Yeah.
You know, that's something that just makes sense to do.
Yeah.
So that's about as far as I've gotten again with this thing. Practice makes perfect, I guess.
Yeah, great.
And I haven't even done too much besides that, but
okay, that's great. That's
my
an introduction. Okay, thank you. Thank you, Daniel, for that introduction to using the T-Tech PC board manufacturing system.
Well, good luck.